All right, welcome to The Explainer. Today, we are diving into a really fundamental shift in how computing works. For years, we've all been sending our data on this super long trip, all the way to the cloud. But what if that was flipped on its head? What if the intelligence could come directly to the data, right where it's being made? Well, that's the big promise of something called edge computing. And get this, by 2025, which is right around the corner, the research firm Gartner is predicting that a mind-boggling 75% of all data generated by businesses is going to be created and processed outside of a traditional centralized cloud. I mean, that's not just a small change, that's a monumental shift in how we even think about data. So what does that actually mean? It means all that computing power is moving out to what we call the edge. But, what is the edge, and why is this happening now? Okay, let's break it all down. Okay, first up, what exactly is edge computing? To really get it, we've got to look at the problem it's designed to solve. See, for years, we've just thrown everything at the cloud, but that's really starting to change. So the official definition is a distributed computing model that brings everything closer to the source of the data. But what does that mean in plain English? Well, think of it like this. It's about putting a mini but super powerful data center right on your device. So your car, your factory floor, even your phone. Instead of sending all that data on a long road trip to some central cloud, edge computing deals with it right there on the spot, the second it's created. And this really lays out the difference perfectly. The old way, the cloud computing model, meant your data had to travel a long, long way. That creates latency, that painful delay while the information is in transit. And man, does it eat up a ton of bandwidth. The new way, edge computing, just flips that whole model on its head. It's all about being instant, super efficient, and, really importantly, keeping your data local and private. Now, you might have heard another term floating around a few years ago, fog computing. And you might be wondering, whatever happened to that? Well, it was an early idea, kind of like a middle layer between your device and the cloud. But honestly, as edge devices themselves got way more powerful and networks like 5G got blazing fast, that middle layer just became, less necessary. The whole industry has pretty much evolved to favor this simpler, more direct connection between the cloud and a really powerful, intelligent edge. All right, so this is where it gets really interesting. What are the big advantages here? Why is this shift so important? Because moving all this computing power to the edge, it's not just some minor technical tweak. Nope, it unlocks some absolutely massive advantages that are literally paving the way for the next wave of technology. And it really comes down to these four big wins. First off, speed. We're talking near instant response times. You absolutely need this for critical applications. You don't want your self-driving car to lag, right? Then there's efficiency. You're not trying to send these massive video files or data streams over the internet anymore, which saves a ton of bandwidth and money. Number 3 is reliability. If the connection to the cloud goes down, no problem. The local system just keeps on working. And finally, and this one is huge, privacy. You're keeping sensitive information local, on the device. It never has to be transmitted in the first place. Okay, so we've covered the advantages in theory. But where is edge computing actually showing up right now? Let's take a look at how this stuff is making a real difference out in the wild. Let's start with connected cars. I mean, think about it. For one car to instantly warn another car about, say, a patch of black ice or an accident just around the bend, it can't wait for a signal to go to the cloud and back. The decision has to be instant. Edge computing lets vehicles talk directly to each other and to the stuff on the side of the road, all in milliseconds. This makes incredible safety features possible, like a see-through view, where your car can literally use the camera feed from the car in front of you to see if it's safe to pass. How cool is that? It's also a total game changer for manufacturing. In a smart factory, you might have a camera that spots a tiny defect on a product zipping down the assembly line. An edge device, right there on the line, analyzes that video feed instantly and tells a robot arm to pull the faulty item. There is literally no time to wait for a cloud server to weigh in. This is quality control happening in real time in the blink of an eye. And this all leads us to maybe the biggest game changer of them all, edge AI. See, for the longest time, AI needed the massive brute force power of giant cloud data centers to work. But now, thanks to all these new specialized chips, really powerful AI models can run directly on the edge devices themselves. We're talking about your phone, your smart camera at home, critical medical equipment. They can now literally think for themselves without needing a constant connection to the internet. But wait, it gets even more clever. AI isn't just an application running on the edge. It's also becoming the edge's own personal bodyguard. This research shows how you can have a tiny, lightweight AI agent just living on an edge device, constantly monitoring the local network for threats. It observes what's happening, makes an instant decision to block or quarantine something suspicious, and then it adapts. It's constantly learning and updating its own defensive strategy all in real time, without needing any central oversight. It's a self-learning security system that reacts instantly, way before a central server would even know there was a problem. So if you've got thousands or maybe even millions of these super smart edge devices scattered all over the world, a brand new problem pops up. How in the world do you manage all of them? Well, this challenge has created a huge new market for something called edge management and orchestration platforms. And to solve this management problem, a whole new ecosystem of companies has jumped in. Of course, you have the big cloud giants, your AWS, Microsoft, Google, and they're all extending their platforms out to the edge. Then you've got AI specialists like NVIDIA building tools specifically to manage fleets of smart devices. And you also have these other leaders creating open source or industrial platforms so that a big factory, for example, isn't totally locked into a single company's tech. The main thing to understand here is that there's no single best platform. It's not one size fits all. The right choice completely depends on the job you need to do. I mean, the system you'd use for managing thousands of AI-powered cameras is going to be totally different from a platform designed for heavy industrial machinery, or one that's built around an open architecture specifically to avoid getting locked in with one vendor. So where is all this heading? What's the end game here? It means that our whole idea of what a data center is completely changing. It's not just some single, giant, faraway building anymore. Computing is becoming truly distributed. It's becoming everywhere. And this quote from the innovator Kareem Arabi just nails it. It's computing that occurs outside of the cloud for applications needing immediate data processing. That's it. It's about bringing the compute power to where it is needed most for all those things that require an immediate split-second response. The future of computing isn't just in the cloud anymore. It really is everywhere. And that leaves us with a pretty fascinating question to think about, doesn't it? If your car, your city, and your factory can all think for themselves in real time, what happens next? As the world around us gets embedded with all this local intelligence, the possibilities are, well, they're pretty much limitless. The edge isn't just where we collect data anymore. It's where our future is being decided, 1 millisecond at a time.